Welcome to our next lesson in biostatistics. In this lesson, we are going to be looking at the method for comparing two different groups. Now, I don't know if you've been around elementary age children recently, but if you ever ask them at recess time, if they want to play a game, what do they want the teams to be? Usually they will tell you, we want boys versus girls. It depends a little bit on the age of the group, but if they've gotten old enough where they're competitive across genders, or they think that the other gender still has cooties, then they want to play boys versus girls. So just kind of framing that in that way. There are a number of different things that we can look at that are comparing two groups, just like the boys versus girls, who has more points, who's taller, all those different kinds of things. So let's take a really quick look back at selecting the best test. We have last module, we looked at all the chi-squares. The last lesson, we looked at simple linear regression and Pearson correlation. Now we are going to be evaluating the independent t-test. And this is a test where we have an interval ratio variable as well as a dichotomous variable. And so if you think of the boys versus girls, this is your dichotomous variable. Anything that can have two categories. It can be well versus sick. It can be illness versus not illness. It can be if you have a protective factor or not, if you have a genetic chromosome that is a certain variant or not. And so anything that is a yes-no variable would be this dichotomous. And again, remember, everything that we're doing here on the top row has an interval ratio variable. And so in this particular situation that I've mapped here, I'm asking you to look at this box and Whiskers graph. We have boys versus girls, and I'm going to say this is probably representative of the 6th grade. Girls tend to hit a growth spurt. They end up being taller than the boys. The boys are somewhat embarrassed about that, and they will catch up and pass the girls later. So here's our average height, and this is possibly not quite representative with the box and Whiskers because this doesn't deal with averages. This deals with medians and interquartile ranges. However, I can't tell you how often I see in the literature box and Whiskers graph for an independent t-test. So we will use that here. That's one way of looking at it. And so if you think about this, this middle part of the box represents 25 or 50% of the population of boys. And then we have some that are shorter or taller than that middle 50%. Same thing here with the girls, middle 50%, median height, as well as extending, that's very bizarre, extending upward and downward to capture all of the possible participants in this particular study. Now, these box and Whiskers graphs, when you see them, I think the reason people use them is because what it represents to them is the shape of what they're seeing. And so it shows the extreme of how tall is the tallest, how short is the shortest, where is the middle. If this box was not symmetrical, it would show that you have some skew, a little bit, a lot. And so this could actually represent, these box and Whiskers could just as likely represent two histograms. And so if you think of all the students that you captured, this would be Johnny, and this would be Joey, and this would be Sally, and Susie, and so on. So these represent the individual students. You see there is a tallest and a shortest for each of the groups, and there's a lot more that are in the middle than there are at the tail ends, and so forth, which is typical of a histogram. And so when I see this, this is what I imagine in my mind. I imagine where the peak is. I can imagine where the highest and lowest, because we're used to dealing in histograms. And so we're comparing these two histograms. And the interesting thing is we're not used to looking at histograms on their side. So what I've done on this next graph is I've put them in the regular dimension that we're used to looking at them. If we have height going this direction, shortest to tallest, we would be able to superimpose them on the same grid. And so here is the mean of these two curves, boys on the left, girls on the right. You can see that they are spread out by a certain distance. However, they also overlap. And so if we just randomly selected a bunch of boys and girls out of the 6th grade from the population, would we be surprised if they were this far apart? So here we have our two groups. There are two groups, boys and girls. Each group has an average, that's the green line, the average height for boys, the average height for girls. Each group also has a distribution. We're going to talk about that in a little bit. And there's a test that allows us to compare the averages of two groups. And so here's the key phrase, compare the averages of two groups. In order to compare the averages of two groups, we would use the independent t-test. Now, I'm going to always be using the words independent t-test, but you also need to know that there are a number of other names for this test if you were to look in different textbooks or in the literature. Sometimes, and I would say this is the second most common thing to call this same test, same exact mathematically test, it's also called the student's t-test. And there's a historical relevance behind that we won't go into right now, but that is also a good name. Independent t-test, student's t-test, they can be used interchangeably. It's descriptive of that test, it's specific of that test, and so both of those can be used very easily. Now, there are two names that this test is called that I would argue against using, at least for you as you're learning about the different tests, and one of them is called a two-sample t-test, and one of them is called an unpaired t-test. Now, the reason I argue against these is that there are actually three kinds of tests. Two of them are two-sample t-tests, the independent and the paired. And so if you say two-sample, there are a lot of people who won't know if you mean the independent or the paired. Also, there are two t-tests that are technically unpaired. And so the one-sample t-test and the independent t-test are both unpaired t-tests. And some people will use this to describe the independent t-test, not realizing that it can also mean something else. And so I would say for the purposes of what we're doing, I would not use those. Recognize that if you're looking in a book and you can't find independent or students anywhere, they're probably calling it something else, just without realizing that that can cause some confusion. So we have two groups, boys and girls. We have an average of something. Here we have average of height, and we are going to compare the averages of those two groups. And so here's the average here. So what would you say for these two groups? If we look at the one up above, would you say that the boys and the girls have different average heights? I would venture to guess that most people would say, yeah, probably. Those two heights are different. Depends on your sample size somewhat. But most people would say it looks like maybe 1, 2, 3, 4, 5 inches different. So that's quite a bit of difference across. However, let's say we look at this graph right here, and here we have boys and girls. This is really, really clear. I've simply just shifted that over to the right. There's such a small area of overlap that just about everybody would say, yes, absolutely. If they're more separated like this, then boys and girls are for sure different average heights. So, and then we have the situation of what if they were less separated? Boys and girls, and here we have a lot of overlap. Looks like an inch difference. It's different, but is it statistically significantly different? And that's really what we're getting at when we're doing hypothesis testing. A lot of people, I think, with this scenario would say, no, they really are not different from each other. So we can see what happens when we move the averages farther apart or closer together. we eventually get to a point where we say, you know what, they don't look like they're really that different from each other. The other thing that we can do is we can change how far spread out each of the groups are. Now here I've taken the same means as we started with, but I've just made it so that there's not very much variability. The boys are a certain height, give or take an inch. The girls are a certain height, give or take about an inch also. And so when you narrow that spread, decrease the variance, it makes them so that the populations certainly don't overlap, and that makes it much clearer about whether those two groups are different from each other. The opposite has somewhat the opposite effect. What if each of the groups were more spread out? They have an increased variance. And so this is another case where we've left the means exactly where they originally were, but if the boys and girls are more spread out, then it makes it look like, well, maybe those two groups aren't really that different from each other. So those are kind of some scenarios where it points out the effect of changing the means and also changing the variance. We're going to see in a minute that this is really, the independent t-test is really a test of variance as much as it is a test of means. Okay, so in summary, we can test whether two means are the same with an independent t-test. The results are dependent on two things: how far apart the averages are, so how far apart the mean lines for each of the two groups, and how wide the variability is for each group. Now, here's kind of a little bit more of an advanced idea. And this will get to what the assumptions are for this independent samples t-test. What if the two groups aren't spread out the same? In other words, they have a different variance. This is called unequal variance, where maybe one group has a wider variance and the other group has a much narrower variance. You'd be surprised how often this happens in real physiologic data, where we've got a couple of different groups and their responses or their disease patterns are quite different in terms of variance. This makes it difficult for the independent samples t-test to run properly. It makes it hard for it to evaluate the difference between the two groups because it uses both the averages and the variance to help make that kind of a decision. And so what you'll see when we run the test is that this unequal variance happens so much of the time. They have included a correction factor right in the test itself. So that was very nice of them. We appreciate that very much, and we need to learn how to interpret that. But when we talk about unequal variance, this is what we're talking about. One group is spread out quite a bit, the other group relatively not so spread out. So, and what we're really trying to find out is whether these averages are the same as each other. So that concludes our introduction to the independent samples t-test. Next, I will show you how to run it in SPSS.